So you've been cruising along, taking your derivatives, learning all about how to find all these different derivatives, and then all of a sudden, out of nowhere, in the middle of all these derivatives, they bring back limits again on us. And you're like, why the heck are we going back to limits? I thought we did all that at the first part of this class. Well, what's happened now that you know how to find a derivative is we have a new limit method that we can apply when we get into some stickier situations. And so what this is called L'Hopital's rule. I'm not going to write out that full name. You can look it up if you need to. L'Hopital's rule has a specific criteria. So the first thing that you have to do before you can apply L'Hopital's rule is show that it works. And so it works when we end up getting out what's known as an indeterminate form. So if the limit as x approaches some number, you don't care what it is, of one equation divided by another equation, if you get out of there 0 over 0 or infinity over infinity, these are what they refer to as indeterminate forms, and it's only when you get one of those formats that you are allowed to apply L'Hopital's rule. So we can't just go running around the world applying L'Hopital's rule whenever we want. So this is going to kind of always be step one, is you got to show them that you are in an indeterminate form. Then after that, what L'Hopital's rule gives us, the punchline of L'Hopital's rule says, well, maybe you cannot calculate out the limit of these two equations here, but the good news is that limit is equal to the limit of those derivatives. So I can take the derivative of the top piece divided by the derivative of the bottom piece. So our derivatives here are never going to be really a quotient rule. You always want to think about these as finding the derivative of the f piece and finding the derivative of the g piece, the bottom piece, sort of individually. And so ideally what ends up happening is you couldn't find the answer to the first problem, but you can find the answer to the second one. And luckily for you, this person, L'Hopital, proved that those two things were equal. And so you get to find the answer to this limit problem that you wouldn't normally be able to solve. So let's get started on this specific example. So here we have the limit as x approaches 0 of x minus the sine of x all over x cubed. So what I always tell people is, you got to show them. You wouldn't have known any better. You start with option 1 for limits, which is just to take your value here and plug it in everywhere you see an x. So out of that, we would get 0 minus the sine of 0 all over 0 cubed. 0 is 0. The sine of 0, you better know your trig stuff like the back of your hand. The sine of 0 is 0. So on top we get 0 minus 0, which is 0. And then on the bottom we get 0 cubed, which is also 0. And so that right there, that is an indeterminate form. And so L'Hopital's applies. They want you to show them that, and they want you to identify that that's how come you get to do the next move. So that little bit of language and work is usually required as you're going through this. What that tells us now is conveniently that we know that that limit we started with is going to be equal to the limit of the derivatives of those pieces. So you look at the top and the bottom individually now, and you find those individual derivatives. Working my way through the top, the derivative of x by itself, that would be 1, minus the derivative of sine, that's a special case, you just have to have it memorized. The derivative of sine is cosine. And then on the bottom, we do the same thing. We take the derivative that's of x cubed, that's a power rule, we get 3x squared. And so here you're basically at a brand new math problem. And so what you do, just like with other limits, at every step is go back to option 1 and see if it all worked out for you. So again, we're going to go back and we're going to plug 0 in everywhere we see an x in this equation. So we end up with 1 minus the cosine of 0 over 3 times 0 squared. So here we get 1 on top, and then the cosine of 0 is also 1. So you get 1 minus 1 gets you 0, and then 3 times 0 on the bottom gets us 0. And oh dang, look what happened. You still have an indeterminate form. So guess what that means? L'Hopital's applies again. L'Hopital's can continue to run. You can keep running this rule until you run into your answer. So Just don't think to yourself it's only going to happen once and you'll get to your answer. A lot of times they want you to run through L'Hopital's 2 or 3 times just to show them that you know it keeps working. So here we're going to go on and we're going to do the same thing. We're going to apply L'Hopital's to this limit here. So we're going to create our new limit as x approaches 0. And again, we create the new limit by finding the derivatives of those individual pieces. So the derivative of the top, the derivative of 1 goes away, that's a constant. The derivative of cosine gives us negative sign. So then we end up with a negative negative, which is going to give us a positive sine of x. And then on the bottom, following our power rule, bring the power down. 2 times 3 gets us 6, and then subtracting 1 from the power gets us 6x. And so here you come through and you do, again, option 1. Plug that 0 in. So we plug 0 in everywhere we see an x. We get the sine of 0 over 6 times 0. The sine of 0 is, again, 0. 6 times 0 is 0, and you're like, ah, man, again, we are at an indeterminate form, and L'Hopital's applies. And so you just keep running through this. It's unfortunate, but that's the way it works sometimes. So we come through here, and now we're taking the derivative of those pieces from that equation to create our next equation. So out of there, looking at the top, the derivative of sine is cosine over the derivative of 6x would just be 6. Back to option 1, plug it in. So we come back and we say, okay, I'm going to take 0 and plug it in everywhere I see an x. So we get the cosine of 0 over, and there's no x on the bottom, so that's 6. So that's a good sign. We know we should be coming to an end because we can't get an indeterminate form with 6 on the bottom. The cosine of 0 is 1. And then 6, the cosine of 0 is 1, then 6 on the bottom, there's no x to plug into that, so that was just 6. And so we finally have an answer that is not an indeterminate form. And that is our final answer. So after doing all of that work, we now know that the limit we started with, the limit as x approaches 0 of x minus the sine of x, all of that over x to the third, that equals 1/6. And we got there by applying L'Hopital's rule 1, 2, 3 times. Sometimes you got to do it a few times before you get to that final answer. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.